Welcome to This Explainer. Today, we're unpacking a genuinely fascinating architectural vulnerability, one that recently let researchers pull off what's basically a massive digital heist on the world's most advanced AI models. We're talking about a flaw that lets people bypass multi-million-dollar security systems without breaking a single cryptographic lock, literally just by exploiting how AI families are built. Okay, let's just dive right into this. Imagine, for a second, if you could see the exact internal monologue of an advanced AI right before it answers your prompt. Think about what's actually going on in the background before the text starts appearing on your screen. What if you could watch it reason, maybe doubt itself, check its memory, and formulate a game plan? So, this internal monologue is what we call a reasoning trace, or a chain of thought, and you better believe it's highly valuable intellectual property. By letting an AI kind of think before it speaks, companies have driven massive leaps in complex problem solving. But here's the catch. This hidden trace acts like a deeply sensitive internal diary. It holds intermediate hypotheses, user data, contextual secrets. Exposing these traces leaves proprietary systems wide open to competitors who want to steal their logic, which is exactly why these companies want to keep those thoughts completely locked down. Part 1. The Hidden Vault. How exactly do AI providers attempt to lock away these valuable digital thoughts? You might assume they just keep them safely locked up in their own private data centers, right? Well, actually, scratch that. It turns out that's not how it works at all. To handle millions of multi-turn conversations without paying for an absolute mountain of server memory, modern AI APIs use what's called a stateless architecture. Instead of storing these dense thoughts on expensive servers, companies encrypt this reasoning into an opaque block of text. Think of it like a digital vault, and they hand it back to you, the user, to hold on to. When you ask your next question, your computer silently hands that encrypted block back to the AI so it remembers its train of thought. Honestly, it's an incredibly efficient system for the providers. But this brings us to part 2, the backdoor exploit. What if the locks on those vaults had a universal master key that was surprisingly easy to exploit? This whole reliance on handing encrypted vaults back and forth introduces a pretty massive vulnerability. Researchers realized they could take an encrypted vault from a tight-lipped, highly secure, expensive frontier AI model and just hand it to a weaker, cheaper, and frankly more gullible sibling model from the exact same provider. Because these models live in the same ecosystem, say moving from a top-tier Claude Opus model down to a cheaper Claude Haiku model, they actually share the exact same underlying cryptographic keys to read those vaults. So the crucial takeaway here is this simple 3-step exploit. First, you capture the encrypted thought from the advanced target model. Second, you pass that encrypted blob over to the weaker, cheaper sibling model. And third, you just use a simple prompt to force the gullible model to transcribe the secrets in plain text. Because the weaker model lacks the hardcore safety training of its big sibling, it acts like an unwitting decryption oracle. It just happily reads the encrypted text and spills all the secrets right onto your screen. Which opens the door to part 3, the 4 heists. By breaking this encryption through cross-model compatibility, adversaries unlocked 4 staggering attack vectors, and the consequences go way beyond just intellectual property theft. First up, distillation. Adversaries can essentially clone proprietary AI logic on the cheap by mass harvesting the brilliant internal reasoning of those frontier models. Second, private data extraction, which, leads to massive unintended data leaks. Third is jailbreaking, where attackers bypass safety filters to access hazardous information. And fourth, invisible prompt injections. This is where malicious instructions are hidden entirely inside the encrypted blocks, literally poisoning long-term agent workflows without anyone noticing. Now, what's really wild is how they proved the jailbreaking vector. Researchers gave a heavily safeguarded model a prompt about how to steal cars, specifically referencing those infamous Kia Boys exploits. The AI's visible answer? Completely safe and benign. It politely refused to help steal a car, but its decoded internal reasoning freely detailed the exact vulnerabilities, literally discussing how thieves break the steering column to start the car with a USB cable. The AI fully reasoned through the crime before deciding to hide it, and this exploit pulled that hidden thought right out into the light. But it gets worse. Part 4, uncovering massive data leaks. Perhaps the most alarming heist isn't even about stealing AI logic or bypassing safety filters. It's about the completely silent leakage of your personal secrets. Researchers scraped public GitHub repositories and Hugging Face datasets, hunting for raw agent session logs that developers had published just for debugging or open source sharing. Using this weaker sibling exploit, they successfully decoded a staggering 315,320 reasoning blocks that developers had unknowingly published online. From those decoded blocks, they uncovered massive real-world data leaks. We're talking 367 pieces of personally identifiable information, 363 technical identifiers, and 182 credentials. And to put that into perspective, this is data from legitimate users who genuinely thought they were just sharing harmless, completely unreadable code blobs. The recovered artifacts are honestly pretty terrifying. They found live AWS secrets, Hugging Face tokens, passwords, personal emails. In one benchmark test, an entirely synthetic persona's passport details, date of birth, and credit card number were totally exposed. And you want to know the craziest part? In a lot of cases, users actively asked the AI to clean up or anonymize the visible chat history before they shared it. But because the AI restated that sensitive data inside its hidden reasoning process, which the users couldn't read since it was just an encrypted base64 text block, the secret stayed trapped inside the blob, fully exposed to absolutely anyone who knew this trick. So, where do we go from here? Part 5, Securing the AI Mind. With such massive stakes, how do we upgrade security and stop this digital heist? The researchers disclosed these findings to the major API providers, who immediately started patching the vulnerabilities. And they proposed 3 main fixes for the industry. First, just stop client-side storage altogether. Move everything to server-side storage, giving the user an unreadable ID tag instead of the actual data payload. Second, implement cryptographic contextual binding. Basically, if you absolutely must send the data to the user, cryptographically bind those keys to that specific user ID and session, so it simply won't decrypt if handed to a different model or user. And third, active provider-side revocation. That means setting up systems to actively track anomalous decryption requests and instantly revoke compromised keys. I'll leave you with this final thought. As AI systems become more autonomous and process highly sensitive personal data, we are facing a massive structural paradox. Think about it. An architectural design that hides a user's own data from them to protect corporate intellectual property leaves them entirely blind to privacy violations. If AI models must hide their thoughts from us to be secure, how can we truly trust their decisions? This tension between corporate secrecy and user transparency is a puzzle we absolutely must solve as AI integrates deeper into our daily lives. Thanks so much for exploring this with me today.